everybody. In this video, we're going to be talking about populations, parameters, samples, and statistics, which is basically like the underlying concept behind how statistics works. So take 3 deep breaths and let's make this math easy. Okay, so to start off this unit, let's start off by talking about what statistics is. So statistics is the science of collecting and analyzing data to infer proportions in a whole from those in a representative sample. So that's a very technical definition, but basically what statistics does is it allows us to collect data and infer conclusions about the population that we collected the data from. So the population of a study is the group that the collected data is intended to describe. So the population could be all SUU students, or it could be all Americans, or it could be everyone who has this certain disease. But the population of a study is the entire group that the data is intended to describe. And then a parameter is a number that is calculated using all of the data from a population. And then a sample is a smaller subset of the entire population. And ideally, you want to do one that fairly represents the whole population. So for example, if the population of a study was all SUU students, then what you would want to do is you would want to get a sample or like a smaller group of SUU students that represents the whole population. So you'd want to have some freshmen, you'd want to have sophomores and juniors and seniors, you'd want to have a pretty good balance of men and women, you'd want to have some traditional students, you'd also want to have some non-traditional students, you'd want to have the different races represented, but a sample is basically a smaller subset of the entire population. And the whole idea of statistics is that you're going to study a sample of your population and use the information that you gather from that sample to infer conclusions about the population as a whole. So a statistic is a number, like an average, a percentage, or something like that, that's calculated by using the data from a sample. And the goal is to design your statistical study in a way that the statistic is going to be pretty close to the parameter. So let's say, for example, we wanted to calculate the average height of SUU students. Well, if I wanted to calculate the average height of SUU students, I could go around and measure every single SUU student and find all of their heights, but that would take forever. And so what I would do instead is I would find a sample of SUU students that represents the entire population pretty fairly. And then I would measure all of the heights of those students and I would find the average height of those students. And when I calculate that average, that would be my statistic. And assuming that I did my study in a fair way where I selected my sample randomly and it really does fairly represent the whole population, my statistic is going to be pretty close to the parameter. And the parameter is not really something that we would ever find because the only way you could calculate a parameter is if you measured every single student at SUU and found that average. So the whole idea is that we're going to find statistics that are close to the actual parameter because you don't want to have to survey everybody in order to find that parameter. So as we're doing the statistics vocabulary assignments, there's a couple other vocabulary terms you should know. First of all, an individual is basically a single member of the population. So in the example where the population was SUU students, an individual would be a single SUU student. A variable is the characteristic of the population you're measuring. So for example, if you were measuring the height of SUU students, the variable would be the height. And the reason it's called a variable is because it varies depending on which individual of the population you're looking at. Some people are taller, some people are shorter, and so the height of SUU students is going to vary between individuals. And then sometimes you will do a survey where the sample is the same as the population. Or in other words, you will survey the entire population. Instead of taking like a smaller subgroup of the population, you'll survey everybody. And if you do that, that's called a census. And we don't do this very often because usually populations are huge and you don't want to have to survey everyone. But there are some situations where a census may be applicable. Like you may have heard of the US Census, where literally everybody in the US answers certain questions about their income and the number of people in their household and, all of these different things. That's called a census. So let's look at some examples of these vocabulary words. So let's say that I was trying to figure out what the favorite pizza place is for SUU students. Well, one way that I could do this is I could ask my class, because I have easy access to ask the people in my class, what their favorite pizza place is in Cedar City. And then let's say that 53 people responded and 32 people said that they prefer Centro, 12 people said they prefer Pizza Cart, and 9 people said they prefer the Hub. Well, in this study, the population that I'm trying to study is SUU students. So SUU students would be the population, and then the sample would be my class, because the SUU students that are in my class are a subset of the entire population. And then an individual would be any individual student, so a single student. And then the variable is the thing that I'm measuring. So this would be the favorite pizza place. And the parameter would be maybe the percentage of people who prefer Centro. And the statistic would be the percentage of people in my class that prefer Centro. So to calculate the statistic, I would say, okay, well, there were 32 people out of 53 people in my class that prefer Centro. And so if I divide those, I get about 60% of my class prefers Centro as their favorite pizza place. Now the parameter, I wouldn't actually be able to calculate this unless I asked every single SUU student what their favorite pizza place was. And so the parameter is something that's unknown, but if I did my sampling in a way that really was fairly representing the entire population, I would assume that my parameter is going to be pretty close to 60%. And so a big part of statistics is figuring out whether your sample really is a fair representative of the population that you're trying to study. But assuming that my sample is a fair representative of the entire population, then I can assume that the statistic that I find is going to be pretty close to the parameter that I would find if I were to actually survey my entire population. So why don't you try this example? In this example, we have researchers who want to determine the average length of trout in a lake. So they catch 20 fish and measure them and find that the average length of the 20 fish is 6.7 inches. Pause this video and write down what is the population, the sample, the individual, parameter, statistic, and variable. So pause this video and write those things down and then restart it to see how I would solve it. Okay, so in this case, our population is all of the trout in the lake. That's what we're trying to study. So we want to find the average length of all of the trout in the lake. And the sample is the 20 fish that the researchers caught. And the individual would be a single fish or a single trout. And then the variable that we're trying to calculate is the length of the trout in the lake. So that's the thing we're measuring. And the statistic that we found is 6.7 inches is the average length of the 20 fish that we caught. So statistics are based on the sample. And the parameter is unknown, because to find the parameter, we would have to literally measure every single trout in the lake and measure them and then average their lengths to find the value for the parameter. And obviously we don't want to catch that many fish. And so we just assume that the parameter is going to be close to the statistic that we measured from the sample. And assuming that our sample is a fair representative of the population as a whole, then that's a reasonable assumption to make that the parameter would be about 6.7 inches. So that's how those definitions work. If you have any questions, let me know, and I hope that you guys have a great day.